let's say that my IA is on the relationship between the area of a boomerang and how well it returns or something like that. And so let's say that I take my boomerang and I calculate the area of it by modeling the top and the bottom edges with parabolas, and that my parabolas happen to be these two parabolas. So the purple parabola is, the equation is y equals negative 0.2x squared plus 10, and the blue parabola is y equals negative 0.1 x squared plus 7. And what I'm looking for is I want to find the area between the two curves. Okay, and the way I do that is I use the integral of the purple function minus the blue function. Okay, so the reason why I do the purple one minus the blue one is because the purple one is bigger than the blue one, at least between the 2 points that I want to integrate from, which is this point and this point. Do you see how the purple function is above the blue function? So let's say the purple function is worth positive 3, the blue function is worth positive 2. We want to subtract 3 minus 2 so that the area turns out to be a positive number, right? So purple function minus blue function if the purple function is above the blue function. Okay? And you say, well, wait a second, what about here? The purple function is below the blue function. Well, we don't care about this area because it's not in the actual boomerang, and we want to calculate the area of the boomerang, which is going to be from here to here. Okay? So inside the integral, obviously, we're going to do purple function minus blue function to get each one of these little rectangles, which we're going to integrate together in order to get the total function. Okay? So each one of these rectangles, the top of the rectangle is the purple function value, and the bottom is the blue function value, right? And we subtract the two in order to get the distance here. So it's going to be purple minus blue function, okay, which gives us the height. What about the width of this? The width of this is like the smaller the better, right? If we chop it up into really narrow rectangles, then that's going to give us a really good estimate. If we chop it into zero width rectangles, we're going to get the best estimate. Actually, it's not actually a zero width rectangle, because a zero width rectangle would give us an area of 0, would give us an area of 0 for the whole boomerang. But if we make it approaching 0 but not getting to 0, then what we can do is we can call it dx, and the dx is going to be approaching 0. So the width of the rectangle is going to be dx. Okay, and inside we're going to have the height of the rectangle, which is going to be the top of the rectangle minus the bottom of the rectangle. So what exactly is x going to range between? Well, x is going to range between this point here and this point here. And how do we find that point? Well, if we were going to use algebra, what we need to do is find when are these two functions equal to each other. So we could do negative 0.2x squared plus 10 equals negative 0.1x squared plus 10. Or plus 7, and then we'll just do algebra and get x by itself on one side. And this is not such a bad algebra problem. I think it would be, we would end up with a positive number if we added plus 0.2x squared to both sides. We'd get 0.1x squared on this side, minus 7 from both sides. We'll get 3 on this side, and then we'll end up with 30 equals x squared. X is equal to plus or minus square root of 30, okay, which square root of 30 is something like 5.48. So it's going to be x equals plus or minus 5.48. Okay, that's how you find the limits of integration. We'll shrink this down and put it in the corner. Okay. So, where do we put that? We're going to put that here and here. We're going to go from this point to this point. And so we're always going to go left to right. So the left point is going to be negative 5.48, and the right point is going to be positive 5.48. Okay? And f of x, purple f of x minus blue f of x is going to be negative 0.2x squared plus 10. Minus, and then we'll put in parentheses because we want to distribute the negative sign, the blue is going to be negative 0.x squared plus 7, right? And then we haven't taken the integral yet, so we leave the integration sign, negative 5 blah blah blah, plus 5 blah blah blah. Don't have enough room to write it there. And then dx. And so then when we integrate this, we're going to have negative 0.2x squared minus a negative 0.1x squared, so that's like a plus 0.1x squared. It's going to be negative 0.1x squared in total. And then we're going to have plus 10 minus a positive 7, so it's going to be 3, right? So now we have taken the integral, or no, we haven't, we've just rewritten it, and we still haven't taken the integral, so we'll leave the integral there. Remember, the integral is from negative 5 blah 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 to plus 5 blah blah blah. Now we'll really take the integral. Now that we have it simplified, I want to take the integral. So I'm going to take the integral. I'm going to get x cubed over 3, and that's going to be negative 1, 0.1 plus 3x, right? That's the integral. And then now that I have taken the integral, I use the book notation, I use the brackets, and then I'm going to say, oh, I need to evaluate it from negative 5.48 to positive 5.48. Okay, and the way I evaluate it is I'm going to plug in 5.48 and get negative 0.1 positive 5.48 cubed, and then in the bottom I'm going to have 3 plus 3 times 5.48, right? And then I'm going to have a minus, and then I'm going to do the same thing, except for this time I'm going to have negative 0.1, and I'm going to have negative 5.48 cubed, oh my gosh, divided by 3, and then here I'm going to have plus 3 times 5.8, which is going to be negative 3 times 5.48, okay? And let's see if anything cancels out. No such luck. I think that we are going to end up with, yeah, nothing's going to cancel out. It's probably easier to do this on your calculator. So maybe you could like group this with this and group this with this, but not an easy. Not something you do quickly with your calculator, although it's not a difficult problem, okay? But if you get to this point, that is most of the points, and that's the hard part, okay? Now, what if we were going to do this on the calculator? What if this was a calculator problem? Well, that'll make some things easier, right? Because like if we program both of these in the calculator, then the process of finding the endpoints would be quite a bit easier, right? We can graph it, and then we can find this point and this point by finding the intersection using second calc intersect. Okay, so let's do that. So the first curve is that, yes. The second curve is that, yes. If you only have two curves in the calculator, that part is a no-brainer. Then what's your guess? Well, since we have two intersections here, let's move the cursor toward this left one first. We're going to find that one first. So it's negative 5.48. That's exactly what we calculated over here using algebra. And then what if we calculate this one? Although it looks symmetrical, just to make sure, why don't we do second calc intersect 5 and then go closer to the other one. Oh wait, first curve, yes. Second curve, yes. What's your guess? And now we're going to move the cursor over to here a little bit. And it says positive 5.48. So now, using the calculator, we have found both the left and the right limits of integration. Then we're actually going to take the integral of this area. And we do have both of the component functions in here, but when we take the integral of the area, we need to do this. We need to have the body of the integral needs to be purple f of x minus blue of f of x. And we figured that out, what it's going to be right here, right? Let's see here. It's going to be this. Before the integral, we don't use the integrated expression because the calculator can do problems where you can't even take the integral. So we just want the subtracted quantity here. So it's going to be negative 0.1 x squared. And then we're going to do plus 3. So that is the result of the purple function minus the blue function. That's what gives us this. And then let's disable these two so that they don't graph. And then if you graph this function, it's going to give you something that might be kind of meaningless. It is an equivalent function. It's one function minus the other. And if we find the area between this function and the x-axis, it's going to give us the same area that if we had found the difference between, the boomerang shape. Okay, so let's now take the integral of this. It's going to be second calc integral, which is 7. And we're going to say the lower limit is negative 5.48, and the upper limit is positive 5.48. And it'll even color in the area, and it'll tell you that the answer is 21.9. And so if we did all this messy math here on the calculator, we should get 21.9 also. Okay, so that is a area between two curves problem. Many of the things that you've used on previous problems you use here. The main difference being that you do need to figure out which of the functions is above the other, and you put that one first in the subtraction, and then the one that's lower is the second one in the subtraction. And then to find the limits of integration, you would find the intersection points. You could do that with algebra, or you could do that with second calc intersect on the calculator. Okay? So, and then remember that if you are using algebra to do and traditional integration, then after you take the integral, you simplify, take the integral, and then make sure you use the book notation to show that you are going to evaluate the integral between the lower and the upper limits, and put the brackets in like that, and then be careful to distribute this negative sign when you're doing the actual subtraction. And this is such a messy one. Didn't feel like doing that and making the video even longer. So, hope that helped you.